Cool.
Okie dokie, let's do a fun one now.
Hell yeah.
Explosives.
Explosive.
And more specifically, God, dying here. What makes a good chemical explosive?
Yeah.
Because we got all different kinds of explosives.
Yeah.
We got chemical explosives, we got nuclear explosives, we just talked about stars exploding.
True.
But what makes an actual good chemical explosive? And I'll tell you right now, it's a combination of three things. And it's a Venn diagram of these things. And the first thing is stable products. I'm going to make this
That
bigger.
should be a little... Yeah. Maybe write out stable products and then
Yeah.
draw a circle around it.
Big.
Yeah.
Big boys.
Hell yeah.
Stable products. That's
Number
next.
one. You gotta be stable.
Stable products.
Yeah.
So basically what you want is you want the energy of the products to be less than the energy of your starting material.
Like your potential energy.
Yeah.
Yeah.
So chemical explosives, let's start with this. What the explosion is an actual chemical reaction. Usually combustion, not always, but usually.
Usually.
So whatever that explosive is burning, and that causes it, and it breaks it down into products, and that converting it into those products releases a crap ton of energy.
And they just burn real fast.
Yeah.
Very
So
exothermic.
it's not necessarily stable products. It's what's called a high enthalpy.
Yeah.
I'm probably going to go into
draw
enthalpy
quickly.
later if I do a thermodynamics video or
Yeah.
kinetics video. But as of right now, and the enthalpy is the difference in energy between the starting material and your products.
Yeah.
So you want that to be as big as possible. So your starting material has a high instability, and your products have a very low stability.
High stability.
High stability.
Low instability.
You're in terms of instability.
Yes.
Instability goes up. Your starting material's up here. Your products are down here.
Okay.
Some good examples of stable products is nitrogen gas, because nitrogen gas is naturally found as two nitrogen molecules in what's called a triple bond. And I realize I haven't done bonding and structures before, which is going to be a bit of a problem for this video. But just take my word at it until we actually do the bonding and structures video. That is one of the most stable bonds we know of.
It's like, imagine holding on to one, it's like your friend's one finger, just holding on to three fingers.
Yeah.
It's a lot more stable.
Imagine this.
A lot more grip.
You have a rock attached to a rope, and you drop it off a cliff.
Yeah.
One rope, it may snap, it may not. Two ropes, less likely to snap. Three ropes, probably not going to snap.
Yeah.
It's the same thing with bonds.
Yeah.
The more bonds, the better.
And
nitrogen has 3 bonds, very stable.
Yeah.
Releases a lot of energy. Another example is, you might not believe this, but explosives produce water.
All right.
Water is a very stable molecule.
Yeah.
Another one is carbon dioxide, also a very stable molecule, also a byproduct of combustion explosives.
Yeah.
Another
Or just
thing,
any combustion, like engine combustion, produces
Yeah.
water and carbon dioxide.
another big part of it is something called bond strain. So again, this is a bit of an issue because I haven't talked about bonds yet, but when things are more than just two things bonded together, you get bond angles.
Yeah.
And if those bond angles get very tight or in uncomfortable positions, there's a lot of strain in those bonds, so it's easy to break them, and breaking them releases a lot of energy.
Just like muscles. When your
Yeah.
muscles are really tight and you're really stressed out, it's really easy to break your muscles.
Yeah.
Or if you're really strained and stressed out, you're probably going to explode for just no reason.
And the last one is a good mix of fuel and oxidizer. So oxidizers are things that are very vital to explosives. An oxidizer is the secondary component to an explosion. most often oxygen, as it gets the name from that, but it can also be something like fluorine. Fluorine is also a good oxidizer.
Or there's a lot of like chemical compounds that just have a shit ton of oxygen in them.
Yeah.
KMNO4.
A good one for fuel and oxidizer combos is making like some kind of like explosive salt and then throwing a, I think that's called perchlorate ion?
Yeah, I think so, yeah.
And then throwing a perchlorate ion on it because it's got 4 oxygens in there.
Yeah.
So that's a good oxidizer, and then throwing that on some carbon-containing explosive ion. Carbon's a really good fuel, and then perchlorate's a good oxidizer. So, and then a very good, I'll get into bond strain when we get to my last example of an explosive, because I want to go over some explosive molecules. Bond strain will come into the last one, which is the chemical explosive with the highest detonation velocity.
Oh.
But for right now, a good combination of fuel and oxidizer plus stable products is the nitro group. So that NO2 is bonded to some part of the molecule. That is a very good source of fuel and oxidizer plus product stables.
Right.
Because you have 2 oxygens on there, plus you have nitrogens, which want to become that stable N2 product.
Yeah.
And you slap that onto some source of fuel.
Yeah.
That's why
2 of those fuel molecules, you get N2.
Yeah. That's why fertilizer is explosive, because it has nitrogen and oxygen inside of it.
Yeah. I mean, I've had some pretty explosive shits, but...
Yeah.
Explosive poops. Sorry, YouTube. Whoa!
Okay, gotta fix that. Give me
Uh-oh.
a minute.
Professionals.
Very, very professional.
Yeah. I might as well clean that up right now.
I was gonna clean it up anyway.
Oh my god, Chance, are those dumbbells? Do you lift? Do you lift, bro?
Oh my god, you are in my gym right now. Okay, so the first chemical explosive. The first chemical explosive. You ever hear of this fun thing called TNT?
Oh, I've heard a lot about TNT. Dynamite?
TNT is actually an acronym for something. It stands for trinitrotoluene. It is a molecule. And I'm going to draw the model for it.
God, I really wish I knew how to draw the AC/DC logo.
So do I.
I mean, it's probably not that hard. It's just AC, lightning bolt, DC.
Yeah, this one. Alright, so very quickly to explain this, because again, I haven't gone into bonding, this is what's called a Lewis diagram of an organic molecule. All you need to know is that the letters are their corresponding elements. Every N is a nitrogen, O is a oxygen, C is a carbon, H is hydrogen.
And then the lines are usually carbon bonds. Or bonds.
The lines are bonds.
Yeah, and if you don't see a letter, it's a carbon.
Yeah, if you on every single joint, if every single joint is a single carbon atom. And so each carbon atom has 4 bonds. And so if you don't see a bond, there's an extra bond to a hydrogen that's not being shown. Like for example, in this corner, there's 1, 2, and 3 bonds on that carbon atom.
Yeah.
There's a 4th one to a hydrogen that's not shown for simplicity's sake. I'm going to get more into this when I talk about structure and bonding, but just for now,
I appreciate the wonderful picture.
Yeah. So this is trinitrotoluene. As you can see from our previous example, this one goes heavy into the stable products and the fuel and oxidizer combo. There's not really bond strain here.
Not too bad.
Because that hexagon in the middle, it's a molecule called benzene. Benzene is one of the most stable organic molecules out there.
Yeah.
So this one tacks very far away from the bond strain.
It's min-maxed. Min bond strain.
It focuses heavily on stable products because of the nitrogen and the nitro groups and the fuel and oxidizer with the nitro groups. And then obviously it eats up the carbon inside of it.
Yeah.
So that's TNT. One of the first, well, not the first, one of the first organic explosives.
One of the first popular explosives.
Yeah, I think it's like one of the first mass-produced explosives.
Also made by Alfred Nobel.
No.
No?
TNT was not Nobel.
Oh.
We're going to get to that next.
Okay.
That one is next. But yeah, TNT was one of the first mass-produced explosives because it's very stable. It's a high explosive. So the difference between a high explosive and a low explosive is how much energy you need to put into it and how much energy you get out.
Oh, okay.
So a low explosive doesn't require a lot of energy. It's very sensitive. Anything will just set it off, and oftentimes you don't get a lot of energy out of it. A high explosive requires a lot of energy to detonate, but when it detonates, it detonates. So TNT is one of the most common, like 100 years ago, high explosives. And the next one is the one... Alright, the next one we're going to talk about is nitroglycerin. This is the molecule Alfred Nobel made.
Yeah, I was just early for once.
Oh god, how does the structure go again? It's... That looks right.
Okay.
That looks right. I'm just gonna go with it.
Alright.
So that is the structure of nitroglycerin. So
It's bonded to the oxygens.
no, it's not. It really isn't. That's not how the nitro group works. Oh fuck. I also added too many carbons.
There is 3 carbons.
Yeah. Oh wow. Okay. Cool. 1, 2, 3.
And then it goes up, and then it's O, and then NO2.
O2.
And just 3 of those.
Okay. Weird.
Yeah, I wonder what you saw.
Yeah, I wonder too.
I found one by ACS that also, same thing. Just looks funky because I have dark mode.
Huh. Wait, what the fuck was that? Okay. This...
If you can, name the molecule we drew. Tell us what it was.
Okay. This is nitroglycerin. This is the actual nitroglycerin, not whatever fucking monstrosity I made.
Oh no.
This molecule actually was not developed by Alfred Nobel.
Okay.
So, funny story about Alfred Nobel. He developed the explosive dynamite. He made it with the express intent to be used for mining and for like clearing away mountains to make train tracks.
Industrial purposes.
Industrial purposes. Of course, no military leader fucking listened to him, so they just started blowing people up with it.
Yeah.
As you do.
Yeah.
And Alfred Nobel had a heart attack, and people thought he died. So he is one of the rare few people that got to read his own obituary. And in it, he saw people thought of him as a merchant of death. And so he made it his life's goal to reverse that status, and so he made the Nobel Peace Prize. Yeah. That is why we have the Nobel Prize in modern day science.
Because shame.
Shame. Man made an explosive that bad people that were in charge of militaries used to kill people.
Yeah, it wasn't even him using it to kill people.
Yeah.
He didn't get any of the fun out of it.
So the thing that
bad
nitroglycerin is a very powerful explosive. It is much more powerful than TNT is because there is more oxidizer. Also, because nitroglycerin is a smaller molecule, in the same amount of space, you can get more molecules of nitroglycerin to pack in there. So you get more bang for your buck.
Those nitro groups are also probably really not happy.
Probably not.
Because those nitrogens have 4 bonds.
Yeah, nitrogen likes to have 3 bonds, not 4.
Yeah.
There's 4 going on there. I'm not showing it.
Yeah,
because
it would be confusing.
But yeah, it's not happy. No. It's not happy. No.
It's real angry. It's gonna blow up.
So, however, nitroglycerin is normally in a liquid form. And liquid nitroglycerin is sensitive as shit.
Just like me, I'm a sensitive little guy.
It's a high explosive because it has a large blast yield, but it's about as sensitive as a low explosive. So it's in a weird gray area. But what Alfred Nobel was able to discover is if you mixed liquid nitroglycerin with something called diatomaceous earth that is called Kielgeser, I think. I might probably pronouncing that wrong. It turns it into this clay-like material that is insensitive to shock.
Is that plastic explosives, basically?
Or
similar?
It's dynamite.
Okay.
He made dynamite.
That's dynamite. Okay.
Yeah.
Dynamite is made with nitroglycerin and diatomaceous earth.
Yeah. And so that diatomaceous earth made nitroglycerin very shock insensitive. So it didn't become this insensitive mess that could just explode if you looked at it wrong.
Yeah.
Now it became a very useful explosive tool.
So that's the thing. You don't want it to blow up while you're handling it.
Yeah, you don't want it. You don't want it to blow up when you don't want it to.
Yeah.
That's the thing about explosives is there's a very particular window of when you want it to explode, and outside of that, it's not a good explosive.
No. There's a very particular window of good time. And outside of the good time, you have bedtime. My God. Wait, cameo? Cameo opportunity? I just go on and draw a little box. So here we have good time. And outside of good time, bedtime. HMX. This makes me think of DMX.
I think this is it.
ACS?
Oh god, how do I draw an octagon? Fuck. Oh god.
Oh, I can draw an octagon. HMX is supposed to be an octagon.
I don't remember what he
It's
said.
it's like a little bulged out square.
Yeah. Oh yeah, you're
Probably-
fucked up, I know.
Just do 4 corners.
Oh, I did get them wrong.
Do 4 corners.
I did get them wrong.
I would do the 4 corners and then bulge it.
And boink boink, boink boink, boink boink, boink boink. And off of the ends is nitro groups. The wonders of chemistry, everybody.
Chance.
Is it RDX?
As you can see.
RDX. Woo.
There's a good time for explosives. And outside a good time, it's bedtime. This is before you want it to blow up, when you want it to blow up, after you want it to blow up. And they're a pain to deal with outside of when you want to blow them up. Because if you want the explosive to blow up and it doesn't blow up, you have what fucking Poland is dealing with. Well, not Poland. France? Belgium?
What?
We fucking unexploded ordinances?
Oh, that's all over Europe, man. World War I and II fucked us up.
Oh, yeah. I don't know how any of that is going to go. Feel free to just cut that whole fucking thing out. But...
Okay, so the next ones I want to talk about are HMX and RDX.
And no, not DMX. Rip DMX.
These things, so funny thing about the naming for these, you'll notice the last two, TNT and nitroglycerin, are named after the molecules. They describe what the molecule looks like.
Yeah.
TNT, trinitrotoluene. It's 3 nitros on a toluene. Nitroglycerin, it's glycerol with nitros on it.
Yeah.
RDX and HMX mean absolutely nothing. Because what militaries found out is that when your explosive is named after the structure of itself, other militaries can figure out how to make it.
No way.
So they made this abomination.
This monstrosity.
Which is like TNT without the carbon on the top, and on the corners that the nitros are attached to is more nitrogen.
Yeah.
Which makes it more...
Oh, God. And it's already part of the way to N2.
Yeah. It's already, like, you added more nitrogen. which means you make more N2, which means the products are even more stable, so you release more energy. And the nitrogens are already bonded together, so all you have to do is kick everything else off.
Yeah. Let's kick it off.
And then they make HMX by just adding more carbon. Nitrogen.
Oh, God.
So RDX and HMX mean absolutely nothing. I'm pretty sure.
Other than bad times.
I'm pretty sure the X is like for explosive, but they named these things RDX and HMX to throw people off.
Heavy metal explosive.
It's not it.
Real deadly explosive.
It's just a random acronym that they made so people wouldn't be able to tell the structure just from the name, like they could with nitroglycerin and TNT.
Yeah.
So that's why those are named that. And then obviously the X is for explosive.
Right. I'm calling them heavy metal explosive and real deadly explosive. You can do whatever you want. You can't stop me. Not with all these explosives I'm going to make.
As of so far, all we've really seen from these explosives is two of the categories. Stable products and fuel and oxidizer mix. Yeah. We haven't really seen bond strain. So, how about I draw a molecule that has all three of them in it?
Hell yeah. The Holy Trinity.
The unholy Trinity.
Chaos, murder, and pillaging.
Okay, let chaos consume you.
Heresy. The unholy Trinity. Nurgle, Korn, and Tzeentch.
The last explosive I want to talk about is this abomination. It is called octanitrocubane. It has our friend, the nitro group, for stable products and fuel and oxidizer. But something I will get into in the structure and bonding video, these carbons in the 8 corners of this cube. This is a cube of carbon. Carbon likes to make what are called tetrahedral bonds. And these tetrahedral bonds have a bond angle, that means an atom to a carbon to another atom, of about 107 degrees. Carbon hates making 90-degree bond angles. As you can see, every single carbon in this molecule is in a 90-degree bond angle.
Yeah.
This molecule is begging for a reason to just fly apart. And that is why this is the theoretically proposed chemical explosive to have the highest detonation velocity of over 10,000 kilometers per second.
Jesus Christ. Hey, what's detonation velocity, Chance?
Detonation velocity is basically how fast something explodes. So when something explodes, it creates a shockwave.
Yeah.
That's what an explosive is. Okay. And the detonation velocity is a measurement of how fast that shockwave moves.
Ah.
And so the faster the shockwave, the more it'll shatter things and then throw them away.
Which makes sense.
Yeah.
Faster it's moving, the more energy it has.
So the slower the detonation velocity, the more it'll just push stuff. The faster the detonation velocity, it'll actually shatter and break things apart.
Yeah.
But yeah, so
I cast Shatter. What? Throws cubane.
So yeah, this is the thing that the only thing I've shown so far that has bond strain.
Yeah.
There's a lot of other explosives that have good bond strain that add to the other groups.
It's just kind of a complicated thing to explain and show.
The tetrazole molecule.
Yeah.
A good video about that is by Explosions on Fire. He makes a compound called bis nitrotetrazolo cobalt perchlorate, which is a very good explosive. His whole channel's about making explosives.
Surprise!
He knows what he's talking about.
Our favorite Aussie chemist.
Yes.
Working out of his
but yeah,
crack
so
shack.
the only problem with this is it is an absolute ball ache to make.
Ball ache.
So
that is
the problem.
Did you get that from Explosions in Fire?
No.
No?
No.
Never
the problem with making a compound with high bond strain is it's hard to make the bonds go that way in the first place.
Yeah.
So it's very hard to make octanitrocubane in high enough quantities to be used for industrial or military purposes. So instead we just use other less difficult explosives that are still good enough.
Yeah. Good enough is the name of the game, kids.
Yeah. When it comes to chemistry, good enough is what you want. You don't need perfection.
Yeah. Me looking at my academic career like, that's good enough. Get me out of here.
So, do you have any questions about explosives?
You know, if you would tell me the topic of these things, I could come with some questions.
That's not... What's the funny in that then?
I'm at my best when I'm at my worst. Oh, I heard that TNT sweats, and that sweat is nitroglycerin. But, like, if you store TNT, it'll just sweat liquid out of it, and the liquid is highly explosive.
So...
But, I don't know.
Maybe? Because nitroglycerin is made the same way TNT is made.
Yeah.
Like, TNT, you make it by taking a toluene and nitrating it to just slap nitroglyphs on it. Nitroglycerin is made the same way. You take a glycerol molecule and just nitrate it until you get nitroglycerin. So they're made the same way. I suppose if you somehow manage to get glycerol near the TNT, the nitro groups could hop over. And so like the TNT swaps its nitro groups with glycerol's hydrogens. Yeah. So it turns back into toluene and makes nitroglycerol. Nitroglycerin? Yeah, nitroglycerin.
Nitroglycerin, yeah.
I don't know about that one.
I know something you don't? Holy shit.
Huh. Yeah, that's
rare.
The first I've heard about that.
Learn something new every day.
Oh, here's something funny. Nitroglycerins can be used as medicine.
Speaking of which, I did a quick Google of HMX.
Yeah.
And apparently it's the abbreviation for Harvard Medical School as well. Which is like, do no harm? Yeah, fucking right. Do lots of harm, more like. Holy shit. God. Yeah. The fuck? The fuck, Harvard?
Okay.
Yeah.
Alright, I'm gonna end it off then. If you have any questions, leave it in the comments below. If you have any corrections or observations you'd like to make yourself, leave a comment down below. I'll pin it to the top. Thank you for watching.
Have a great day. Good afternoon, good morning, and good night.